In section 5.5, we're going to discuss solving nonlinear inequalities. A nonlinear inequality is something that looks like this. So for our first example, we're not just going to solve, but we're also going to graph on a number line and write our answer in interval notation. As we'll do with all of our problems. So here's our first example. Let's solve x minus 3 squared times x plus 1 is less than or equal to 0. Okay, so this example right here is a nonlinear inequality because of the squared also multiplying the two x terms together, x factors together. So this actually, linear would just have an x to the 1 only, and it'd be quite easy. We could just isolate the x on one side. Nonlinear means we can't just isolate x on one side. There's too many other things going on. So here's what we're going to do instead. The numbers that are of utmost importance to us are called boundary points. Sometimes they're called critical points. Sometimes your textbook even calls them zeros. All are totally appropriate, and these are when you have x minus 3, for example, equals 0, x plus 1 equals 0. So these points are whenever the factors of our inequality equal 0, hence the term 0. You'll see in a second why they're called boundary points and critical points. So here's what we get. We've got the two boundary points are x equals 3 and x equals negative 1. Now I'd like to show you what a picture of the function f of x equals x minus 3 squared and x plus 1 looks like, and discuss what it means to be less than or equal to 0. There we go. Here's a great picture of that function. Here's what I want you to notice. Our boundary points, critical points, zeros, whatever you want to call them, are 3, which would be here, and negative 1, which would be here. Now, yes, they're x-intercepts, that's true, but this is what we care about for this inequality. For this inequality, we're looking for what are the x values that make this graph less than or equal to 0. Let me be more specific. What are the x values that make the y values for this graph less than or equal to 0 or negative? Well, those would be here. Y's would be negative here. Oh my gosh, only there. And they equal 0 over here. So here's what we've got. If we're looking for where are the x values that make that function less than or equal to 0, we're looking for this region up to negative 1 and including negative 1, and 3, just for a brief second, because it does equal 0 at 3. So what I wanted to show you by showing you the graph, we're not going to graph this just yet. That's for later in the semester. Right now, we're just going to solve that inequality. So I'm going to have the graph go away while we're solving it, but I want to bring this back around so you can kind of reanalyze the graph after you see the solution. I just want you to notice for right now that these boundary points or critical points or zeros are very, very important because they're where our graph changes from negative to positive y values or from positive to negative y values, and that's what we're concerned about. So while our first step will be to find the boundary points, the second step will be to create what we call a sign chart. Sign meaning plus or minus sign. So here's what a sign chart looks like. I'm going to graph the number line. And on it, I'm going to label the boundary points. So -1 and 3. Okay, these boundary points are going to create columns for me. So what I have right now is 3 columns. All of the x values, remember this number line is just the x-axis. All of the x values that are less than -1, all of the x's that are between -1 and 3, and all of the x values that are bigger than 3. So to complete the sign chart, what we're going to do is we're going to pick x values in each column. And I'll do this in green so that you can follow along. So I think a nice easy one to pick way over here is maybe -2. And I'm going to plug that in to my inequality. So -2 minus 3 squared, -2 plus 1 is less than or equal to 0. So that would be -5 squared, -1 less than or equal to 0. 25 times -1, you know, that is less than or equal to 0. So I'm going to write true right there, because we got 25, -25 is less than or equal to 0. That's true. And I'm going to keep going. I'm going to pick 0 in here in the middle column. So plugging that in, I have 0 minus 3 squared, 0 plus 1 is less than or equal to 0. And I want to see if I get true or false out. So this would be -3 squared times 1. 9 times 1. Oh, that's not true. 9 is less than or equal to 0. That's false. Okay, and then I'll plug something in over here like, I don't know, 5. So 5 minus 3 squared, 5 plus 1 less than or equal to 0. That's 2 squared times 6, which would be 24. That is also false. So when you complete your sign chart, the reason they call it a sign chart, like plus and minus sign, is because all you care about is your function less than or equal to 0 or greater than or equal to 0? You're really just looking at the signs. I did a little bit more arithmetic than is really necessary. When we're writing our answer for these, we always want to include, let me scooch this up, just the true column or columns. So our solution is any true columns. And for this problem, that would be just our column on the far left. That column we would write as -infinity to -1, always putting parentheses at the infinities. For the -1, we would want to put a bracket because we do want to include the times that our polynomial equals 0. So we'll have a bracket at the -1. Now this problem is a little bit trickier than a lot of problems you might have encountered in intermediate algebra because there's one other spot where we have a solution. Certainly not in the false columns that we have over here on the right side, but since we have equals to 0, we have one spot where it also equals 0, and that is right at the value x equals 3. So one way to write that is union the number 3. That one little extra piece takes this from an intermediate algebra problem to a college level algebra problem. So let's try another that's just like it. For our second example, let's solve graph on a number line and write our answer in interval notation. The inequality x minus 4 times x minus 5 quantity squared times x plus 2 is also now greater than or equal to 0. Actually, I would like to change that. Instead of having another greater than or equal to, I would like to change that to just greater than 0. Okay, so following the steps we did in the last one are, I'll call them boundary points. Those would be pretty easy to spot. Those would be when x minus 4 is 0, so x is 4. When x minus 5 is 0, so x is 5. And when x plus 2 is 0, so x is negative 2. So we have x equals 4, x equals 5, and x equals negative 2. Then we want to create our sign chart by drawing in a number line and labeling our boundary points on it. So here's negative 2. That's going to create a column. Way over here is 4. And then right next to it is 5. Terrific. Okay, same idea. We're going to pick test points within each of these columns. We have now 1, 2, 3, 4 columns here. And then I'm going to show you a slight shortcut we can use. So let's pick for our first one, let's pick something over here, maybe x equals, I don't know, negative 10. Okay, and when I plug in x equals negative 10 for the first one, I'm going to show all the arithmetic just so we get some practice. So let's see, we have, I'm going to go down here, negative 10 minus 4, negative 10 minus 5 quantity squared, and negative 10 plus 2 is hopefully greater than 0. And this actually looks good. This is negative 14. This is negative 15, but it's being squared. And this is negative 8 is greater than 0. So what we have here, and this is the part that I'm going to skip to for the next couple columns, is a negative number, negative 14. Negative 15 is negative, but we square it, so that will be a positive number, and negative 8 is a negative number. A negative times a positive times a negative is definitely greater than 0, so we have true for our first column. Okay, let's go to the next column. Something between negative 2 and 4. Ooh, 0. Let's pick 0. Now, I can do all this arithmetic, no problem. It's not difficult with a calculator. I could even figure out what number this works out to be. But I'm hoping you've done this before, so maybe we can skip a bit of the arithmetic and go straight to the positives and negatives for the signs. So plugging in x equals 0, 0 minus 4 would be a negative number for our first set of parentheses. 0 minus 5 is negative, but it's being squared. So when we have a negative number that we square, that is going to be positive all the time. And finally, 0 plus 2 is definitely a positive number. So we want to see if this is positive. Ooh, this does not look good. A negative times a positive is not greater than 0. So our second column is a false column. And you should get false, by the way, regardless of what number you pick between negative 2 and 4. If you picked x equals 3.9, you should still get something that is false. Okay. Let's do this sign component, forego the arithmetic, when we do our next column. So between negative 4 and 5, positive 4 and 5, let's do 4.5. So when we pick 4.5 for x and plug it in, 4.5 minus 4 is positive. It doesn't matter what x is here. X minus 5, because it's being squared, will always be positive. And 4.5 plus 2 is certainly positive. So we have a positive times a positive times a positive. That's totally greater than 0. So we have true. Now, before we get excited and go, oh, look, it's alternating. True, false, true, this is false. Watch what happens on the other side of 5. So if we pick something, like let's say we pick x equals 100. If I pick a big number like x in a column that allows me to, it makes my mental arithmetic, when I plug it in, much easier to do for the plus and minus signs. So plugging in x equals 100, 100 minus 4, definitely positive. Like we discussed earlier, anything squared is always going to be positive. And 100 plus 2 is certainly positive, so we again have 3 positive numbers multiplying together bigger than 0, which is true. Okay, an important thing to note about why it did not alternate on either side of the 5 from true back to false is it's because the x minus 5, so the x equals 5 boundary point came from the x minus 5 squared. It's because that is being squared. That factor there is being squared. Since this is an even exponent, since that's an even exponent, it will not alternate true, false, true around the x equals 5. However, the other exponents that are odd, because they are 1s for each one of these, the odd exponent boundary points, x equals 4 and x equals -2, they will alternate true to false or false to true around the -2 and the +4. So a little shortcut, I'll bring it up again in the next example, a little shortcut, if you look for even exponents, they won't alternate true, false on either side of the even exponent. Okay, remember for writing our answer, let me scooch this up. We want only the true columns. So step number 3, our solution is all of the true columns, which in this case would be the column on the far left is -infinity to -2. Since this inequality was simply greater than and didn't have an equals to sign, then parentheses all the way around. So -infinity to -2 with parentheses, union, because we want to skip the false column, 4 to 5, the interval from 4 to 5, union 5 to infinity for our last true column on the far right. Okay. All right. Let me box this answer, make a quick comment about those last 2 columns. A lot of times when I teach this class, I get the question, Mary Beth, how come it doesn't have the answer -infinity to -2 union 4 to infinity? Why didn't you just include these in one? And that's because that's not possible. That's because right here, we need to skip x equals 5 since we do not have a greater than or equal to. If we had a greater than or equal to, and these were brackets here and here by the 5, then everything between 4 and 5, including 5, and everything bigger than 5 would just be everything bigger than 4. But the parentheses here, since we don't have an equals to sign, we had to put them in there. This means we're skipping the number x equals 5. It's not included in our answer. Okay, let's do another problem and we'll practice more of these same concepts. Okay, I'm going to shorten the directions to solve, graph, interval, meaning solve the inequality, graph it on a number line, and write our answer as interval notation. And let's do x to the fourth is less than or equal to 16x squared. Okay. It's not factored for us. Well, we can get it there. So let's get 0 on one side. So x to the fourth minus 16x squared is less than or equal to 0. Factor out the GCF of x squared, leaving us with x squared minus 16. And that leaves us with, x squared times x minus 4 times x plus 4 is less than or equal to 0. Very cool. Okay, so step number 1, our boundary points. They would be x equals 0, 4, and negative 4, looking at the factored version of our inequality here. Okay, second step is our sign chart. And on the sign chart, we'll label negative 4 and 0 and 4 and give us those columns at each of those points. Terrific. Okay, let's fill in the sign chart. So for our first number way over here, let's pick negative 100 for x on the far left. And I'm picking a number that's really big so I can make the mental arithmetic easier. Notice x squared, when we plug any number in for x, we're always going to have a positive for the x squared. Negative 100 minus 4 is certainly negative. Negative 100 plus 4 is also negative, and we want this to be less than or equal to 0. But a positive times a negative is a positive number. That is not less than or equal to 0, so we have false for our first column. Okay, now if you want to use the shortcut, look at the x value you have here for your boundary point, negative 4. That came from x plus 4. Since the exponent on the x plus 4 factor is odd, then it will alternate true, false, true, and so on around x equals negative 4. So I know without doing arithmetic that if I pick any number in here, say I pick negative 2, I should get true, because x equals negative 4 came from the x plus 4 factor that had an odd exponent. If you don't want to remember that, that's okay. You can always pick your x equals negative 2 and plug it in. But notice what happens when I pick x equals negative 2. Sure enough, x squared is always positive. Negative 2 minus 4 is certainly negative, and negative 2 plus 4 is positive. And a positive times a negative times a positive is definitely negative, less than or equal to 0, so I get true. So if you wanted to skip this little piece right here, you can take a look at whether it alternates or not. Looking at x equals 0, by the way, that came from this factor, the x squared. And since that factor is even, it will not alternate. True, false, true. So this should be true again. And sure enough, say we plug in x equals 2. Anything squared is always going to be positive. 2 minus 4 is certainly negative, and 2 plus 4 is positive. That is definitely going to be less than or equal to 0. So we definitely get a true. And then finally, x equals 4 comes from the x minus 4. Since it, like the x plus 4, has an odd exponent, it should alternate the trues and falses, so it should go back to false. But if you want to verify that, pick a number for x, plug it in, and verify that you get false. Okay, writing or answer. Let me scooch these guys up so we can write our answer. So writing our solution, we want our true columns. Okay, so I want this column and this column for my answers. Need to take a look at whether we have strict less than or less than and equal to. Since we have less than and equal to, we want brackets. So let's go back to that discussion we had before. This -4 to 0 union 0 to 4 is a very cumbersome way of saying just the interval from -4 to 4. Because what the first set of intervals means is every number between -4 and 0, including -4 and including 0, combined with every number between 0 and 4, including 0 and including 4. Well, sure, that's just everything between -4 and +4, including the -4 and the +4. So this would be, the first way of writing it with the union would be an unsimplified version of just writing -4 to 4. However, for comparison's sake, if it were -4 to 0 with a parenthesis and 0 to 4, and the parentheses were on the zeros, then you cannot combine it into -4 to 4. Okay, so whether you have brackets or parentheses on the 0 in the middle, on the number in the middle, that tells you whether you can combine it into a single interval or have to leave it as 2. Okay, let's move to another type of nonlinear inequalities where we have rational inequalities.